in 2 months. Transactions comes every month. IEEE AWPL, that's letters, it's a 4-page maximum. Then you have IET journal, which is the Indian journal, which is also good. IET, which is UK-based journal, and then Proceedings IEEE. So you can sort of choose, depending on the contents of your paper. I think you can choose any one of them. It is application-oriented, then I would say AP Magazine is the best. If it is analysis, a lot of theoretical work, I think AP Transactions is good. But if it is a quick publication and you want to show the results, so AWPL Letters is good. That's 4-page maximum, and others are also good. So conference, as I said, conference publication is important to improve your network with other professionals. Journal publications get professional recognition and more. I think if your paper is good, I think you'll get a lot of emails and a lot of good feedback. So people think that I have so many papers, thousands of papers, but that's not important. And that's meaningless. I think quality is more important. So how you define the quality? So the quality is defined by citations. So that means if your paper is cited many times, that means a lot of people used your paper. And so citation index, like either Google Citation Index or other H index, these things are taken as standard. For example, if you're evaluating IEEE fellow, so those things are very important. So that basically shows that your paper is high quality if you have high citation index. So don't worry about the quantity. I think one good paper is worth more than 20 average papers. So try to publish quality papers. So how to publish? So the key thing I tell is don't rush your publication. I think people are always in a hurry to publish, but in that they do a lot of mistakes. So, and you have to prepare very well. I think you have to put your thoughts and you have to do a lot of work before you publish. So you have to think yourself. You are the best judge, so you can think whether you can publish your paper or not. Do a lot of literature search in that area you want to publish. Say microstrip arrays. You can refer a lot of publications and see. And not only doing the literature search, but then you need to identify the novelty. What is what your paper differs from what was published prior art, previously in the literature. So that's, if novelty is not there nowadays, I think that's one of the important factors. I'm the associate editor for Transactions, AP Magazine, and also AWPL. So I think all these 3 magazines look into the novelty. So if the novelty is not there, it will be rejected. So you cannot just repeat what people have done with maybe different simulation methods and present results and compare. So that's not much added value. So show some novelty and describe how your paper is different from the prior art. Keep it short and sweet. So long papers are not good because you're wasting everybody's time, and also you're wasting pages in the valuable transactions, because each transactions, they have a yearly quota, about 3,000 pages or 3,500 pages. So I think you have to, if you write one paper 15, 20 pages, I think you're robbing two more papers of your colleagues. So it's always, I think, short papers are try to limit it to 7 pages or less. So anything long papers, I think even reviewers get fed up with long sentences and long descriptions. So keep it short and sweet, so you'll have a good chance of publication. Quality of figures and tables are very important. Sometimes I see figures not very legible. Tables have a lot of stuff in the tables, and you cannot sort of see really what the message is. So figures and tables should convey the message very easily. So they're very good because you don't need to write too much. So once you put a figure, I think people can see either comparison between computations and measurements or something else. I think you can, or return loss bandwidth. If you come up with a design where it gives 100% bandwidth, I think you can show that. So I think the quality of figures and tables are very important. So it also gives a good impression for the reviewers when they see, okay, this is good, and that's important. So short papers, well-written papers have good chance of publication. So when you write, make sure that your English is important, grammar is very important, writing style is important. Always use the short sentences. So that makes it very easy to understand. So if you are in doubt, maybe you get it reviewed by your peers, maybe colleagues, or maybe other students or researchers, or even other professors. So nothing wrong in that. So always second set of eyes is more important than your own eyes. I think you'll be thinking in your own domain and saying that, oh, what a great paper I have. But others will critique it and they say, okay, change this, change that, but be open to that criticism. I think technical criticism is always good, and it will improve your technical qualities as well. So revise. So don't just write a paper and submit it. You revise. I think second. Am I audible?
Yeah, sir, your voice is breaking. Yeah, some noise is coming. And now it's okay, sir. Now it's okay. Yeah, it's again.
Can Arunraj mute your mic?
Yeah, Mr. Arunraj sir, please mute your mic. Yeah, Mr. Arunraj sir.
I think it's coming from others.
Arunraj. Okay, sir. Okay, sir.
So revise. I think that's the secret for quality submissions. So read 2 times, 3 times, 4 times, 5 times. Each time you'll find a mistake. So I think that's very important. I think the contents are also important. I think generally the contents are title. So don't put any long titles, just apt titles. So title should convey what the paper is about. Abstract will basically tells you, include the novelty, why your paper is different from the others. So basically it will summarize what you're telling in the paper. So that's very important. Title and abstract, I think they basically catch the eye of the reviewers. So those things are important. Introduction. So this is, I think, long introduction. Some people write like 2-3 pages. So that's not, that's waste of time and waste of everybody's time. So just tell the importance of the work. What are the applications, prior art, some references, how they have done, and what is the new work presented in the paper, how different it is from the previous work. So that should be basically the introduction. And then you will have main sections about 3 or 4. So typically design, analysis, fab and test, comparisons, etc. So I think generally 3 sections are enough. Sometimes people put more sections. It's up to them. But each section should be self-sufficient by itself. So if you're doing the design, you tell how you design it, then how you analyze it, and then if you're doing some fabrication and test, how you have done and show some results, and then comparison between if you have different analysis or analysis versus measurements, etc. And then summary, conclusions, and acknowledgement. Acknowledgement is also very important because if you're a student, I think you're supported by a grant or your university. So don't forget to acknowledge whoever contributed. References, I think that's important. Don't give a long list of references, though reference won't count as a page. Now I think the new policy is without the references, it should be like 7 pages. Longer papers are okay, but then it will take more time. And sometimes you have to pay as well. So there's no need to refer to 30, 40 papers. Refer to only those things which are important Of course, those references will have the previous references, so you don't need to add all the references. I would say maybe 15 should be the maximum references. In some cases, it may be more or less, but so the reason I sort of show this because it's not my paper. So this is actually, I didn't want to write, but Callan Ostrud is my summer intern from UCLA. He's actually a bachelor student. He joined me when he's doing his second year. He came for 3 summers and actually did he can do independently himself. I think has done almost PhD type work by the time he left. So he wanted the paper, so I said, okay, we'll write it. So the reason I put it here is this is the first time I think accepted, we submitted, and within not even 3 months, I think 2.5 months, they said it's accepted. So no revisions, nothing. So you can refer to that, and if you're interested, you can see how it is written and why it is accepted first time. So then you submit it, and then this is the review process. So when you submit it, use IEEE format, which is double column type format. So try to keep it 7 pages. Once you submit, the editor-in-chief will allocate the papers to an associate editor. So typically that takes about 1 week. AE then assigns the reviewers, 3 to 4. Minimum you need is 2 reviewers. So generally, I keep about 3 to 4 reviewers. Reviewers are given about 4 weeks to submit the report. So what are the choices? Either accept, minor revisions, major revisions, reject, and in some journals we have reject and resubmit, like AWPL has reject and resubmit. So generally most of the papers get major revisions and then maybe minor revisions, and then probably if it is properly done, it will be accepted. So I think you don't want to go like 2 revisions, at least probably 1 revision is fine. Sometimes if the quality is not good, novelty is not there, it will reject. So don't get discouraged if it is rejected. So try to improve upon and look at the comments. Generally, the reviewer will provide the comments, and that will be sent to you as well, to the others. So minimum 2 weeks required. If the reviews are not consistent, then minimum 2 reviews are required. So sometimes one reviewer says accept, others say major revisions or reject. So then it's a contradiction. So we need to send to another reviewer. So we cannot, associate editor cannot review the paper. So he has to send to another reviewer. So that will take some time. So that's why, to save time, I normally send to 3 or 4 reviewers. So then associate editor summarizes and makes recommendation to AIC. Sometimes there are also track editors, track associate editors, depending on the field. I think they will also act as EACs. So that takes about 1 week. So then EAC makes the final decision, and generally I think whatever AE recommends, it will be done unless there is a conflict or so that takes, so totally takes about 4 months to get the first recommendation or first response for your paper. So that's why then if you have to revise, then it will take another 2 to 3 months. So that's why it's important to write the best you can when you submit the first time. So that's why first paper publication is precious to any author. So it motivates you to write more, and be careful not to overpublish. That's also not good. A good paper with lots of citations is worth more than 10 average papers. So try to write good papers and useful papers. Lots of competition now to publish. Some countries like China pay heavily for authors. If their paper is published, they pay almost like $2,000 or more. So that's why they publish in they send papers in quantities, not by quality. So they want the money. So that's not good actually. So there's some concern about in the IEEE journals about what to do with these papers. Because as a reviewer, I think you're like associate editor. Like I see a lot of papers like that. So you have to go through the process, but it burdens a lot of people. So IEEE has to decide what to do with that. Do good work, prepare well, and good luck with your first publication. So that's all on publications. So next, a couple of charts I'll show on innovation. So what is innovation? So it is a process of translating an idea or invention into goods or services that create value for which customers will pay. So if you don't have value for your creation, then the innovation is not very good. So it should always should have some commercial value. So to be called an innovation, an idea must be replicable at an economical cost and must satisfy specific need. So that means it should have some commercial or some industrial value to it. So actually IEEE mission is important. So IEEE mission gives importance to innovation. So core purpose of IEEE is to foster technological innovation and excellence for the benefit of humanity. So I think it's the same motto for most of the high-tech companies. So they're very proud to sort of display their patents. And if you have some patents, I think you'll get some royalties. So they support you a lot. So what is innovation? Why do people innovate? Paper versus patent. So these are the things we'll go through. How to innovate and get a patent or trade secret. So I'll show a couple of examples of innovation. So what is innovation? So innovation is not imitation. So it's not a minor improvement over prior inventions. It's not like a paper. So you do some minor improvements on the paper and then publish. So that's not. So you should have some originality in the innovation, and it should have some commercial value as well. So it's an out-of-box idea or concept. It should result in a product, a concept, or method. So it's a new idea, creative thought, new imagination in the form of device or method. So it's application of better solution meeting new requirements. So invention is the result of innovation. So you innovate first and then you think of applying for the invention. So inventions are often protected by patents and trade secrets. One example is USPTO. That's what we have in US, United States Patent and Trademark Office. Same thing they have in Europe as well, and India also has a patent office. So Japan has its own patent office. So sometimes if the patent is has a value, so you try to your company will promote to apply other places also, so that they prevent others to use it without paying royalty. So sometimes I have some European as well as Japanese patents as well. So innovation typically happens by necessity. Sometimes it happens by accident. You get a crazy thought in the middle of the night, and then you woke up and go down quickly and try to document something and go back to sleep. So that's how it starts, at least in my case sometimes. So sometimes you plan it. So I think anything you plan, I think it's not good, I would say. It should come out of box like an accident, or by necessity it should come. So you don't plan any invention, but some people do that. So end product of invention is an improved product, a patent or a trademark. We all have innovative minds. I think it's not like one has a great mind than the other. We all have innovative minds, but just have to channel our thoughts properly in a more focused way. So this is, I told many times, this is a famous quote from Steve Jobs, ex-CEO of Apple. Innovation distinguishes leaders from followers. So you don't want to follow for somebody for a long time. I think you follow in the beginning of your career, but then you have to show your leadership when you go into your med career or when you become senior person. Why innovate? So companies want you to innovate because they want to keep that, they want to prevent other companies to use your idea. So because they have certain 20 years or so, they'll have the patent is valid for about 20 years. So it has societal benefits, like you get royalties from the company. Sometimes you get, it also helps society to advance the technology, like iPhone is one good example. GPS is another example of innovation. Professional satisfaction. So it's basically engineering pride. So engineers don't care about papers much. If it comes, I think that's fine. But if you have an invention, that means a lot. So monetary benefits you get. And I think you get personal satisfaction also. And then you tend to work with passion afterwards. So this is engineers innovate and researchers publish. So if you are an engineer in the industry, I think it's good to, you have to innovate because that's necessary nowadays, I think. And researchers, of course, they have to publish. And of course, the researchers can also innovate and engineers can publish, but main function of engineering is to innovate or develop products. Function of academicians is to do research and publish. Patent versus paper. Technical paper is basically a result of research in particular area. It could be analysis, improved design. So it's basically science. Patent is the result of engineering, a new product. Engineering a new product is depends on the application. So if you're working in satellite business, you have to develop the products that suits the satellite environment. If you're working in aerospace, then their constraints are different. So you have to know them and you have to develop accordingly. Same thing for the ground antennas. So they're basically science versus engineering. So academic is, I would call it science. Engineering is basically professionals and working in the industry. So both are important. So if you're an engineer, understand the requirements first. So that is very important. Sometimes we forget about what the customer wants and give them something which they don't want. So think outside the box for solutions. So there's nothing, same design you cannot repeat because customers are different, their requirements are different. So each time I think you have to come up with a new design. So persistence is important. Sometimes you may not, your design may not work well, it might fail, but you have to be persistent and you have to improve upon and deliver the product. So teamwork is important. So if you're an engineer, you have to work with mechanical engineers, system engineers, and payload engineers, antenna engineers, technicians. Measurements is important. So you have to go to the range and see how your design is tested. So if you don't go to the range and sit on the desk and simulate, it's useless. So if you're an engineer, you need to do all this. Patent is worth several publications and more, I told you before. So some question, I think patent, this is a classical question comes. So somebody invented a pencil a long time back. So, okay, you sharpen the pencil, you write it, that's good. So when we were elementary school students, I think we used to do that. So that's the invention of the pencil, which was done many decades, probably not decades, centuries back. So then somebody came up and added a eraser on top. So before we used to take the pencil, separate the eraser and in the geometry box. So you write, and if something is wrong, you take the eraser and erase it and keep it. So somebody came up, why not I combine these two together? So he put a eraser on top of the pencil with a holder on it. So that's a pencil with an eraser. So question is, can B be patented if A has already been patented? So the answer is yes, because it combines the two functions together and improves the product. So it's a new invention. So so if you improve on some antenna design and come up with a slightly use the old design but improve the design by adding some features to it, sure, it can be patented. How to innovate and obtain a patent? So innovation requires understanding of requirements and focus on key requirements. You should know the knowledge of prior patents in that field. So you need to have analytical software, hardware knowledge, because eventually you need to develop a product with more capability. So it's mostly multidisciplinary areas. So it's not just RF by itself. So RF mechanical, you need to know manufacturing, you need to know systems, you need to know how to test it. So novelty is very important. So hard work. So the reason I think you need to do hard work is every week, I think on Tuesday, you get ESPTO releases issued patents. So there's an antenna. If you click on the antenna area, there'll be about 400 of them. So sometimes all are not related to the field you work, but at least about 50, 60 are related to. So you need to go through them weekly basis. You need to make it a habit. And every Thursday you get applications. So applications is before they issue the patent. Sometimes the company wants to publish the application so that nobody attempts to work in that area. So that comes every Thursday. So they're also important because then you know what people are working on. So it's not very good if you sit in your own cubbyhole and in your company and think that it's the whole world. That's not good. So you need to know what Europeans are doing, other companies are doing, what Asians are doing. So that actually broadens your knowledge. So that requires some hard work and discipline. So I think so patent is an outcome of the innovation process. So complete the work first and think of patenting, not the other way. You don't plan to apply for the patent. You first do the work, then you judge yourself whether it's worth patenting. So do your research, check the prior art, and then you think you have some merit in it, then you apply for the patent. Procedure, so you can go to ESPTO, EPO, which is European Patent Office, and other patent office as well. The Indian Patent Office you have, Japanese they have. So you first file an invention disclosure with your company or yourself and get approval for filing. So selected this, so it's not like all disclosures are selected for patenting. Some are preferred to keep as a trade secret, so they don't want to publish outside. If it is very, very important, like then they'll try to keep it as a trade secret. So each patent costs about 20K to file it, the lawyer fee, etc., US dollars. So it's a cost. So you need to prepare a PowerPoint package and attach with the disclosure so that when the lawyer is trying to draft your patent, so he can go through the PowerPoint package and then he'll call you, then you discuss with him what is important, what is not important, how to. So he'll ask a lot of questions, so you need to answer them. So finally, they'll submit to USPTO for review. Takes about 3 to 4 years to get a patent, whereas papers you can publish in less than 1 year. So it's a very tedious process to get a patent. So patent application, it has title, abstract, has background, prior art, publications, etc. And it's a detailed description and drawings you need to submit. Claims, so these are very important. So these claims, I think you want to keep them as broad as possible so that you cover all the areas so that people cannot copy. So typically there'll be 20 claims. So broader claims are preferred. Patents that are most difficult to copy are highly beneficial to the company. So that's why they'll ask whether somebody can copy and how you sort of find out easily. So those things are, and if they cannot copy, so they'll ask permission for the company to use it, and they have to pay royalties. So companies get a lot of royalties. I think my company gets almost about $100 million per year on the royalties. So type of patents, provisional patent, that is mainly to, it has a validity of 1 year. So basic aim of provisional patent is you get a date. So if you apply now, I think it will take about a week. So next week you'll get a date, some date. So if similar patent is applied after that, so you'll get the priority. So other patent will be rejected. So that's why it's important to file the provisional first. So, and then the utility patent. So that's the most desirable. So validity is for about 20 years. So you get all the rights. So design patents are also there. Validity is 15 years. So, but it does not protect the functionality. It protects the design, but it doesn't protect the functionality. It doesn't cost that much, but value is a bit less. So normally I don't do the design patents. Trade secret with the company. Sometimes it's very important for the company to protect the IP. So they'll just label it as trade secret and keep it the company locker. So they don't publish outside. So nobody knows. So you need to work with patent attorney for patent application submission, and later when the examiner sends the reports, some claims he rejects, he'll tell the reason. Then you have to respond to that, why you think that claim should be valid. So I think that goes through. So when you go through all that and the examiner agrees, I think you'll get a patent from the US United States Patent Office. So something like this. So some examples, I won't dwell on it, bring 1 or 2 examples. This is one of my patents. So this has been, the value is tremendous because there are commercial satellites in corners from 90° west to almost 120° west. So
Sir, Sudhagarao sir,
Yeah.
sorry for interrupting. And we have Dr. Shamsundar Patnaik sir. He is ready for next session. And when we start
Okay.
his session now, he can join ministry by 11:30, sir.
Okay. No,
Okay.
mine is almost done.
Okay, sir. Okay, sir. I
Yeah.
just inform you, sir.
Yeah. So here we came up with a design where you take into all the big orbital arc from 90° west to 120° west, and then you, because each orbital slot, your coverage area changes. So then we use roll and pitch biases to make the composite coverage of all the orbital arc as small as possible. So that way you can go with one design and you can put in any orbital slot with using pitch and roll biases of the satellite. So that got significant cost savings. So this has been employed over 20 satellites in US and Europe as well. So this is the multi-beam antennas. I think probably the first one to do multi-beam antenna for direct broadcast satellites for local channel broadcasting. So it has a number of patents. So I think I discussed this in my talk as well. So this is very difficult design. So the way we did is using high efficiency horns instead of corrugated horns. Gives almost 90% efficiency, combined with some improvements on the reflector, like step reflector design, so that it can cover multiple frequency bands. So this can do up to 5 frequency bands covering DBS, reverse DBS, and also PCS. Some testing using during TVAC, thermal vacuum testing. So this is a device which is saved millions of dollars because we used to, this is at Lockheed Martin we did. So we used to get the absorber box. We used to lease them for about 6 months, cost about $3 million. So then they're fed up with that and then asked me to look into come with our own design. So we call it pickup horn method. So basically you put that pickup horn in front of your flight horn. So of course with some spacing. So it has some cooling. LN2 goes inside and outside, take the heats out on the 2 side panels. So this cost only $150K. And main thing is the schedule is saved from typically TBAC testing of all the payloads. Different payloads takes about 3 months. So this we can finish all in 1 week. We don't need to close and open the vacuum chamber doors. So tremendous saving in cost, and Lockheed Martin used it on probably 12 satellites so far. And European wants to get the royalties to use it, but I think the company has rejected that. So that's all. So innovation should be the daily part of engineers' professional career. So when you go to work, always go with enthusiasm. Don't go like why I should go to work. So that's not good. So always go with enthusiasm, and it shows up actually. So every day, I think you think of something new. So thanks, Professor Raghavan, for sort of putting this burden on me, and Professor Shankar and organizers of STTP Phase 3 for allowing me to present this.
Sir,
Thank you, sir.
Sir,
Madam, any questions?
sir, there are more than 20 questions, sir. Sir,
Yeah,
after
yes,
the-
sir.
Dr. Patnaik, please join, sir, because Patnaik has joined to ministry now. So after that, please, people are waiting to ask the questions. So
Okay.
I request Professor Sudhakar Rao to join after Dr. Patnaik's class. Thank you, sir. Thank you, sir. Thank you, sir.
Okay, thank you, sir. Thank you very much, Sudhakar Rao, sir. Thank you very much, sir, for sharing your valuable knowledge with us and for being with us today. Thank you, sir.
Thank you.
Dr. Shamsundar, sir.
Yes, good morning.
Good morning, sir. Able to hear?
Yes, I can hear.
Okay,
loud
shall we
and
start
clear.
our next session, sir?
Yes, please. We can go ahead.
Okay.
Oh, can I take
Welcome.
over now?
Yes, sir.
Can I take over, or you would like to?
Yeah. I would like to invite you, sir. Welcome, Dr. Ravindra K. Misra. I invite Dr. Ravindra K. Misra, Samanta Chandra Shekhar Award Professor, Professor Electronic Science and Technology, Berhampur University, Bihar, to say a few words about Dr. Shamsundar Patnaik, sir. Sir, I welcome you, sir. Ravindra, sir. Ravindra, sir, are you able to hear me?
Sir, madam, I think he's having some mic. You can continue, madam.
Okay, sir. The next session on the topic textile antenna, biomedical antenna, and soft computing is handled by Dr. Shamsundar Patnaik. Dr. Shamsundar Patnaik is presently the Director of National Institute of Technical Teachers Training and Research, Chandigarh. The institute is an autonomous institute of Ministry of Human Resource and Development, Government of India, established in the year 1967. Before joining to the post of director, Professor Patnaik served as Vice Chancellor of Biju Patnaik University of Technology, a technical university of Government of Odisha. Professor Shamsundar Patnaik completed his postdoctoral research from the University of Uttar, USA, and PhD in engineering from Sambalpur University, Odisha. Under the supervision and guidance of Professor Patnaik, 21 students have completed their PhDs, and currently one more is pursuing his PhD work. He has 52 MA theses to his credit and has published 272 papers in journals and conferences of repute. He has 2 international books and 4 international book chapters to his credit, a recipient of Boy Scout Fellowship from DST, Government of India. Professor Patnaik is also awarded with Sir Visiting Fellowship, INCA Visiting Fellowship, UGC Visiting Fellowship, Distinguished Faculty Award, National Educational Excellence Award, National Scholarship, Best Paper Award, etc. He is also listed in WHO's WHO in the world. He is a life fellow of IETE, life member of IST, and senior member of IEEE, USA. Professor Patnaik is a non-researcher in the field of antenna and soft computing under application to biomedical. He is the brain behind the use of Google Hangout to conduct faculty training programs, thus giving a new dimension to digital pedagogy. During this tenure, as Vice Chancellor, Professor Patnaik brought out many innovative approaches in the university to give a new thought process to the development of technical education in the state of Odisha. Professor Shamsundar Patnaik is involved in the various national and international committees in the capacity of chairman and member. We welcome you, sir, to our STT program. I hand over the session to Dr. Shamsundar Patnaik. Sir, I welcome you once again.
Thank you, Madam, for such a nice introduction. Esteemed Professor Raghavan, Professor Sankar, and all the esteemed speakers and learned participants. Namaskar and good morning again to all of you. In fact, as you know, after holding the chair of Vice Chancellor and Directors, you become the intellectual clerk rather than being a researcher. So I admit that candidly, that yes, there was a time when I had wonderful 23 students, all have completed now. It is not 21, all the 23 students, they have completed their PhD under me. They did wonderful works, and some of their works I am going to share, because at this moment I am more busy with the administration work rather than being a researcher. It is difficult. In fact, I am trying to become an academician, continue to become an academician, but it is really difficult sitting in that chair once you get involved in institutional affairs and many committees. Definitely this institute where I am serving now, they are more into the technical teachers training, and also it is a QIP center for PhD. And in that situation, you are more towards the educational policies, and also you'll be busy with doing some activities which is more like going for implementing the policies and also participating in creating the policies. So my recent activities is more towards like going for better pedagogical approach. So presently we have actually decided to go for a socio-digital pedagogy. So that socio-digital pedagogy is a different type of aspect which I'll be talking in different forum, but this particular forum was requested by Professor Perumal, and when Professor Raghavan asked me, I was slightly having this hesitation that what to speak. Actually, so far actually my area is getting confined to more towards education rather than research. So that's the reason actually I was trying if I can skip that and go for something different forum. But nevertheless, we have certain informations with us. I would like to share with the young researchers, because the young researchers ultimately they have to take the baton forward, and I personally feel that certain area which are less touched or has lot of potential, this can really help you. Maybe my this presentation today will excite some of you to go for this type of area of research. Basically the biomedical application, when we are not talking about smart medicals, like I have a good friend in this Narayan Hudralaya in Bangalore. We both used to be the board members of some university, and he used to share how he has hired computer science engineer to become a smart medicals, and the type of inputs he gives about engineers in the medical science. It is really fascinating. So therefore, I see that maybe a day will come when you'll see that RF medicals, where a lot of these RF people are in the medical domain, and they are doing extraordinary contribution, like we have done in many research establishment, we have done in space research establishment, like that. So that is the way I look forward to a situation when you'll see that a lot of these RF engineers are more into more into like the applications of antennas in the medical areas. So let me just share my PPT, then I'll come back again. I'm having a problem in sharing here. Madam, एक minute आओ इधर.
Yeah, it's getting loaded, sir. I think it will take some time.
Oh, generally, actually, if I click this arrow, immediately it should come.
Yeah, it's getting loaded, sir.
Procedure is very simple. Share your entire screen, then click there, go for the total screen.
Yeah.
Sir, I think, sir, screen is shared now.
Pardon?
Pardon, sir.
Screen is already shared, sir. So you can just open the PPT.
Screen is set.
Yes, sir. Yes, sir. It's very clear, sir.
So
It's visible. It's visible. You
PPT
can put in your slideshow, sir.
okay, so I'll go to the slideshow. Just give me 1 minute. I'll go
Okay,
to
sir.
the first slide so that is it visible now?
Yeah, it's clear, sir. It's good.
Okay, okay, that's fine. So maybe it was in background. I was not in a position to see that. Okay, so what I was referring is that this medical science or the medical areas, they demands a lot of our RF engineers intervention, sir. And but it is stopped. The area is stopped when you are trying to convince the doctors. They don't get convinced so easily. And since I have certain backgrounds of working with the doctors in our activities, and also like some of my PhD students, their work were more towards the medical applications, so I could understand the mindset of the doctors and how to make a team with that. Like Dr. Rao was talking in his talk that it is a system level requirement, and antenna as an isolated system component has no meaning. So when you talk about the system level applications without partners, without networking, it is not possible. Therefore, I nowadays advocate partnership builds strength, networking creates wealth, and empowering is the mantra of progress. So that is the way my administration also I follow, and in antenna system, it is very much fit into the type of requirement. The type of topic which I would like to cover because of my next scheduled meeting at 11:30, which is a very important national level meeting, I have to be there because I have to present certain agendas there. So therefore, I'll be slightly hurrying up in my presentation. Sorry for that, but definitely you can raise this question. I'll come back later, maybe through email to Professor Shankar. I'll share the answers. So basically what I'm going to talk here, how you can really play with the brain. Mainly the work started way back in 2013-14 when I seriously wanted to give a solution towards the brain dead people. But after that, I became vice chancellor. The work really didn't take up to that type of patentable level, but the work started and people started getting their PhD degree. But my intention was in 10 years' time, we were supposed to give a some product to the society that the society could have utilized that for a brain dead people. But the way the things are happening or the way I got involved in administration, it is really getting delayed. That's the reason we have started sharing this information with everybody so that whoever is interested in this area, they can work into this. So here I would like to show you certain things, how in a phantom level measurements takes place. Even if it is a old slides, maybe some of you will have some ideas how actually when you are going for some biological study of RF radiations or biological study of some RF interactions, how actually you do. You cannot directly put a human being in front of the RF exposure to have some data for yourself. So you have to go through certain phantom studies. Like Professor Rao was telling, simulation, yes, you can have a first-hand information, but ultimately you have to come to the experimental test bench to validate your the simulation results, and after that you have to go for the practical utilization of those products. So that's the way. So this is an anechoic chamber where we used to have the antenna testing using this human head, where the this material used to have the equivalent electrical properties of a human head, and this pink color material which you see here, this is that soft tissue equivalent materials having the electrical properties same as our what we have in our system. So this is the way the setup used to be there. As the turntable moves, we used to get a lot of data. I'll just skip this part. This is just to give an idea. Then nowadays you'll find a lot of these parameters are available: conductivity, permittivity, your name any type of parameters at different frequencies are now available. So you can really create the equivalent materials and create the phantoms to which you want to utilize. So this is the way, like if you see the bone has these properties, fat, muscles. So a lot of this type of database are available nowadays. Earlier it was very limited. Now a lot of people have done good research and very precision values are available, and people who are interested to do that, even while creating the simulation materials, is that they can also think of putting this type of practical results which are available in different forums. So basically, one of the important thing when we talk about the RF interaction with the biological systems, and that matter human body parts, one of the important parameters which comes into our mind is SAR, the specific absorption rate. So even when you buy a phone, you might have seen it is mandatory for everybody to disclose the SAR values. And what is this SAR is all about? The SAR is basically, in a layman term, says that if you get exposed using this device, then how much radiations in terms of RF will be getting absorbed in your body parts. If you are nearer to head, how much it will get absorbed. It is nearer to hand, how much it will get absorbed. If it is nearer to your chest, how much it will absorb. So different type of locations, different type of electrical properties are there. So obviously there will be interaction of these electrical radiations, or so-called the RF radiations, and you will have some amount of absorption in your organs or the body parts which is getting exposed to this RF radiations. So if you see here, this SAR is basically proportional to the conductivity and also to the peak field to which you are getting exposed. But at the same time, it is inversely proportional to density, means that if your size of the organs or size of the body parts is more, then obviously your exposure or the SAR value get reduced. So keep in your mind that if the body part which is more conductive in nature, they are more prone to having more RF exposure. And also if the field which you are radiating, if the peak field is more, obviously more absorption is expected. So this is a mathematical expression for defining the SAR. And that is what the soft region of our brain, they observe more than the hard region of the brain. This very well you can see from this FDTD simulation of a lambda by 4 monopole antenna at this 835 megahertz. So where the phantom in a simulation, FDTD simulation, we try to find out how much deposition has taken place. If you see here, the deposition in the soft regions are more, where you'll have reddish and the yellowish color, whereas the blue regions are basically the slightly hard region, so the deposition is less here. So similarly, I told you, as the size changes, our size changes, as the head size changes, the deposition with the bigger head size will be less, and the lower head size it will be more. In that case, if you see here, as adult, our head size is more, whereas a small child of 5 years or 10 years, their head size is small. So we intercept more signal, but our soft tissue region is less compared to the child. So therefore, even if their head size is small, means the receiving antenna is small, then but their deposition is more because of the conductivity material, which is soft in nature, is more in child than the human being. That's the type of simulation result which we obtain when we work in these areas. So you'll find that the adult compared to adult, the child are more prone. Therefore, it is said that don't get your child exposed to longer time to the mobile phones. Then also we did some study to different positions of our own posture, because we don't keep vertical our phone. Sometimes we rotate ourselves, phone get rotated. So we did varieties of studies, but I have just given you some limited information here. So this really gives a overall idea that if you are really interested to work in the area of biological interface or the biological interaction with the human body, then a lot of this type of holistical analysis is required, and it is beyond your antenna chapter. So you have to integrate those chapter with your antenna knowledge to explore these areas. Then since the biological applications requires a different type of application areas, then we thought that maybe smart uniform people are talking. The warfare system will have lot of sensors, and with the upcoming 5G, 6G, and already in their condition stage, and also in the advent of 3D printing, and now people are talking about the 4D printing, where the material characteristics also can be changed to a large extent. So with the facilities available in the doorstep, like 3D printing, possible 4D in future, 5G, and possible 6G in future, so many openings or many floodgates are getting opened. So this will definitely help us to go a long way in better biological or medical oriented antennas to be developed by the individual experts or as a team. And I personally feel if you look at the nano requirements, with the size of the nano properties you can change. So we antenna engineers generally play with the materials and the material properties. So that material properties and their different type of geometries are basically we play and try to get the answer to the difficult situation for which the antenna answers are required for. So that way, if you see, we sincerely look into those type of possibilities here in NITAT Chandigarh. Fortunately, we got a very good nano group now. They are the people not into the theoretical alone. They know how to compose different type of nanomaterials. They create nanomaterials. They experimentally measure the properties of nanomaterials. So one of my students who has joined as associate professor in this institute now, he has a background of antenna, soft computing, and biological antennas. Now these people are getting clubbed, and they are looking forward to some nano biomaterial antennas, which maybe when something will come out, I'll come in front of you, or maybe this color will come in front of you, who is associate professor here to present. But in wearable antenna, we started working way back in 2010-11. We explore various possibilities. This is a security guards situation, then the school bag, where we tried, then even our belt, like this is my belt where I'm wearing an antenna on my belt. So here, if you see different location also we tried. But the challenging aspect is that intentionally I kept a rough antenna in front of you. If you see that the stitching, you have to go through a machine only to stitch, and the stitching will have uniform gaps. It will lead to air gaps. It will have non-uniformity in this type of lining. So a lot of those challenges are there when you really go for a cloth antennas. So the cloth antenna challenges are comparatively more compared to normal substrate antenna, which is more uniform and homogeneous in nature. Here heterogeneity comes to a large extent. So therefore, when we talk about the textile antenna, especially multi-layer textile antennas, it requires a different type of approach how to keep the multi-layers in a uniformity. It is really difficult because you have to stitch multi-layers, pasting them. Again, the adhesive will have issues, and you have to analyze the properties of the adhesives. And when you are stitching, the stitching has a uniform air gap. How to take care of these air gaps in your substrate analysis, those things are also to be seen. So the textile antenna also, they go through the bending. So bending effect also will come into picture, because when you are putting them in pockets or shoulder, in a pant or any type of things, it is prone to different type of bending situation. So the bending analysis also has to be done. So this particular work we started as an trial and error experiment basis, but later on we developed FDTD code for that. We simulated those bending effect using the FDTD code, and also we created different type of material properties for that. If you see here, we are taking jeans, we are taking normal cloths, so varieties of things, polyester, many such substrates are tried, and also the bending effects are tried in various type of materials. So after the FDTD simulation results were obtained, we tried that in different substrate, putting them in different substrate, and also tried to see how the things are happening in the experimental bench. So that is like we took solder size, we bend them to a solder situations. If you see here, these are the structures which are mapped to somebody's shoulders, and accordingly the antenna is put to see the bending effect in that. So with this background, now I'll come to my main topic, the topic on which I want your attention. That the biological study is definitely a different type of approach. You must have a good understanding of the different electrical properties of the organ which you are dealing, and also you must have a good understanding how the SAR measurements takes place, or SAR FDTT simulation takes place, all those things. In addition to this, the cloth, because more or less you'll be more interested to put these as a uniform antennas or textile antennas. So therefore I gave some information on this textile antenna. But if you need further beyond this, Dr. Jayant Gajanan Joshi, who is in Nasik, is doing wonderful work. Professor Raghavan, in fact, I remember saying sometimes past, when we used to present this textile antenna, I used to tell that it is Joshi's antenna, because he was my PhD KIP students here, and when he started working in this area, Professor Raghavan is very closely associated with our team, so he is a very esteemed and respected professor for us. So he knows each and individual student of my group. So he, in a very funding way, he used to tell this is Joshi's antenna. So that so further you can also contact Jayant Gajanan Joshi. He will be in a position to give you more inputs, because he has done recently a number of new development in this antenna structure. Now coming to the conceptual thing which we would like to discuss, and certain results which we have obtained, we would like to share with you. The idea was that, as you know, our RF radiation has intervention with our heart functioning. It is a very clear-cut established fact that when there is a radiation and we are exposed to this radiation field, our organ like heart and the heart waves, they pass through certain type of variations. At the same times, in our brain, we have different type of waves, but here the four prime waves I have discussed: beta, alpha, theta, and delta. So if you look into this type of waves, I intentionally have avoided the other small component, but these are the prime wave of the brain signal. When we talk about ECG signal, we talk about gamma wave, beta wave, alpha wave, theta wave, delta wave, like that. So the idea was that I was really interested that when a person gets affected, something happens in his brain. Some neuron, they don't get the firing potential. So when that particular neurons doesn't fire, then the chain gets blocked, and subsequently other neurons, they don't get firing potential, and that affects the control system, and the person goes into the coma or paralysis. All these effects happens to him. But it is difficult to really find out, localize the particular neurons and acting on that particular neurons. It is not that easy to find out which location exactly is getting affected and how to do that. So therefore, there are many blind therapies which are tried as a trial and error. Sometimes it clicks, sometimes it doesn't, and therefore the patients are left to the blind therapy analysis. But the approach was here is to how to really create a change in the brain wave. If the neurons are not getting the potentials to fire, can the outside interference through antenna, because as you measure the SAR, we have signal getting deposited in our head in different locations. Already I've shown you that in experimental way also. I have handled, I have worked in these areas. So that's gave me a thought process that if I am using a mobile phone or I am using any external radiators, it is affecting my brain waves, because it is getting deposited in my different location of the brain. With this deposition, can I create a local effect in the brain for those people who are having a neural problems? Can I bring a solution to those neural problems by external radiation therapy? So that basically a wild thought forced me to explore and take a challenge with two of my students, and I gave them this problem, and they had definitely had gone through some frustration initial stage. because it was a difficult area to really explore. But today we have certain data where if you are interested, definitely you can take next step easily. But initially we are in the blind, and we are discussing this in a. So then while searching for the literature, then we found that there are certain sites where the literatures are available, where they have certain database where they talk about the heart rate. And the heart rate of different conditions in your emotions, in your frustration, in your appreciations, those conditions, heart rate, brain waves have been studied. So that again helped me to understand this subject more. If you see here, with our state of mind or state of heart, like appreciation, frustration, we say it is a frustrated mind, it is a frustrated heart. So like that, if you see, the noisy signal comes when you are frustrated. When you are appreciated, maybe it is a soothing approach, and the signal is more smooth compared to the frustration stage. Similarly, we came across certain coherent study analysis where we saw that the heart rate variability, respirations, and the blood pressure rhythm, they are linked. So basically, the respiration can control the heart rate variability, that controls the blood pressure. This is all known thing. That's why maybe Guru Ramdev, he talks about Anulam Bilayam, where the respiration you control. Based on this respiration control, the heart rate is changed, and the heart rate ultimately takes care of your blood pressure's requirement as a controller. Similarly, when we saw this cardiac synchronized alpha activities, that gave me the idea about the brain, how it works. In a normal situations, our baseline goes like this. So if you are normal, nothing is really more exciting is happening to you, then your distribution of the signal will be like this. But when you are, suppose you are given a very good appreciation, your boss is telling you have done a wonderful job. Once you are reaching to your director, he is also telling that, oh, I'm really happy that you have done a lot of things and you should be awarded this, that. And when you come to your family or society, a lot of people are appreciating you, then your brain waves get excited, and in that way, if you see, the distribution is something like this. And interestingly, when it compares with the female and male, interestingly, you'll see that this distribution in male, it goes beyond the heart. It just comes down distributed over the more part of the hearts, whereas in female, it is more towards a central part, which is more concentrated. That's why when you come to the house with some good news, your mother runs, hug you like that. Your father will give a small smile. You think, what is this man? He's not appreciating my achievement, but it is not correct. He is equally giving you that appreciation and that praise, but unfortunately, the God has made the male in such a way that that signal get distributed more in different localized way, distributed way, and in female it is more localized way. That's the reason. Then we came across some areas that I was exploring how to enter the brain. It is not that easy that you can really enter the brain that way. Then we found that in the field analysis, the heart electrical field is 60 times stronger than the brain electrical field. And in terms of magnetic field, the heart magnetic field is 5,000 times greater than the magnetic field of the brain. So that gave me an idea that look, if you want to create a perturbation, so better to enter into a strong field, so that a small change in that field will be create a visible delta perturbation. So with that delta perturbation, you can really work on the bringing the change to the brain. So then we came across some article which shows that the heart and brain, they communicate with each other, and they talk to each other. The heart talks more, brain talks less, but there is a bi-directional communication happening between heart and brain. So when this particular literature we came across, then it was the idea that we'll go to the brain through heart, because the heart fields are more compared to the brain, and therefore the perturbation can be created better in heart. And since heart is talking to the brain, so let's try to explore entering to the brain through heart. Then how to really enter into the heart? I cannot prick a needle inside your heart. Therefore, I started searching, and then we came across certain literature where it says that The skin is the best interface. Any disturbance when you are creating, it will go through the heart to the brain. So then creating disturbance in the skin was in our control, because there were already two types of antennas which had biocompatible jelly as the substrate. So on this substrate you have metallic strip. Those metallic strips used to be act as antennas. Like many such things we came across, where if you see here, this is a biointerface substrate, top of which you have this metallic structure. This is the antenna structure which was pasted on this jelly, and with this they were in a position to create the disturbance in the brain. So this gave us the idea that yes, there is a possibility that through skin with a bio interface substrate, you will be in a position to really interact with the heart, and through heart you can really try to reach to those brain region where you can play with those neurons to help these brain dead people. It was definitely was a very wild, ambitious project in my mind, and I put two people's career in stake, because both the PhD students, they had to go through a lot of frustration, but now luckily everybody got their success and everybody got their degrees. But that time it was a blind type of approach, but today it is not that scenarios. A lot of other things are also available. So therefore I'll suggest that you can explore this field. This is a very interesting field. Then we started taking the EEG approach. Then in ECG study, we started getting the ECG recorded in our lab, and it's HRB. So interestingly, we found that the people who are more exposed to the mobile, those students, we tried with transmission mode and reception mode. That when they're receiving a call, we took their ECG, got the HRB. They were made to make a call, and their ECG was taken, and HRB was also calculated for that. And we took care that it is purely isolated. There must not be any radiation coming from the mobile to the ECG system or the sensors. So that is the way we took care everything. Or in this type of research, let me tell you, your methodology, the experimental setup is challenged like anything. So you must try to vet it through doctors. The doctors should certify that whatever bench which you have created, that bench is taking care of your objectives which you are defining. Luckily, in my institute, the campus doctor is a senior cardiologist, and he was asked to the lab. He only helped us in fixing up the test bench, and accordingly in that test bench we started taking the signals. And the signal, to our surprise, the people who were into meditations, these people who were into constant doing this type of routine meditation activities, their HRV was more smooth compared to the students who were more towards the mobile. The students who were more engaged in mobiles, it was found that they have a different type of HRB in place. But another interesting which we saw in a particular student, that generally if you see the peak is inverted here. Generally it is not the case. It is reverse way. If you see our PQRS, when you are going, this peak is slightly more than this peak. Whereas in case of one of the student, we found it is reverse. Then we went to the doctor and also consulted another senior consultant, PGI. They told, no, sometimes this type of situations arises in some students, but it is normal. Don't get confused, because I see he read the ECG. He told is completely normal art. So you need not worry for this thing. This type of things are visual. So we started taking this HRB, and we found different type of variations in the HRB. Then we took the PhD. So the power spectral density analysis we did. Here I didn't give you all results, but I am giving you. So once you do the power spectral density, because from this reading you may not get the things detailing, only doctor can tell what is happening. But we communication people, we are more fond of with this term called power spectral density. So once we go through this power spectral density analysis, then we could realize yes, this mobile radiations has impact on heart, and it is changing from person to person. The person who are into meditation, they have a different type of power spectral density, whereas the people who are into different type of applications, very continuously using the mobile, they have different distributions. And also there is a variation in the your transmission mode and reception mode. If you see here, the transmission mode has a different power spectral density. When it same person reception mode, it has a different type of spectral density. So after doing this type of analysis with the ECG signal and different posture also, like if you see here, this is a person who was using mobile for number of hours in a day. So her type of studies were different. Then also we took different posture study, like keeping it in pocket and holding in hand, holding in near to head. So various studies we did, and then we came across different type of observation in terms of RR, HR, RH, pH, QRS. If you see, we created a real reasonable database with 75 subjects who gave volunteer contribution for this. Then the matter started that what type of data analysis we'll do. Then we decided to go with linear, nonlinear, all parameters, so that we'll take care of the nonlinear, linear study, and we'll see where the variations are really happening. Then these are the parameters. If you see the frequency band, then the Vagal, then the your BPM, mean, maxima, skew, delta, PP interval, all those things are covered. Then we came to the EEG study, because initially it was ECG. We took study on the heart first, then we tried to see how the EEGs are working. So the people are simultaneously given this exposure, that they are asked to talk, also receive signal, and we started taking their HRB as well as their EEG signal simultaneously, because we want to see the sync, how they are correlated. So initially the normal recording was done using the normal postures, where the eye is closed, the blinking noise is avoided. And we took a lot of filters exercise also to see that the ECG signal or the trace is accepted by the doctors. So the doctors also gave this, they also vetted that yes, this is the right kind of signal which you are getting. Then you can see the same person now is asked to go for a mobile call. So in this case, he is making a call, and we started recording his EEG recording. So that is the way the EEG recordings were done. So if you see, like different subjects also we have taken, and that is the way the EEG acquisition takes place. Then we use different filters, because ultimately from this particular signal, if I give you this signal, it is very difficult to come out with some analysis. So therefore we started going for different type of windows, and based on these windows we took different intervals, and based on this interval we started making the, if you see here, it is if you see the same person, it is in 3G transmission mode. It is the ECG signal and its corresponding EEG signal. So ECG and EEG simultaneously, which were captured, now it is kept in a small window, expanded, and this is now created like this type of thing. So therefore, a lot of these ECG filters and EEG filter specifications were with trial and error we took, and the trace was justified. After this trace were taken after using the filter, creating that window, these traces were justified or vetted by the cardiologist. So then we use this type of approach, like extracted P, extracted QRS, extracted T waves, and if you see here the P, Q, T, like that in terms of ECG and its corresponding EEG. The corresponding EEG collected during that time and try to map to that. So then, as you know, the parietal, central, focal, occipital, like that. You have different locations of the brain. So that is the way. If you see here C3P3, C3P3, so these locations are basically different node locations. When you are having sensors at different locations, based on these sensor locations, you are getting this type of signals. So these signals were taken, and there we did a coherence analysis. It was necessary to see that are you really getting certain variations because of these ECG variations or not. So we did a coherence study. If you see here the coherence study, it is in the different mobile conditions, ideal. Then you have 2G receive, 2G transmission, to 3G receive, to 3G transmission, and also like different location of your the EG sensor node. It is C3P3, it is C4P4, that is central and perennial. It is central and perennial. Just give me 1 minute. Colonel Sahab, I am in a session. Actually, I'll join at 11:30 only. I have given you mail. Yeah, I'm trying to hurry up. Actually, I'm not doing justice to my session today, but I'll be positively there by 11:30. Oh, thank you. So this different type of, if you see, a lot of this type of database was created. If you frontal and central, the coherence, and again F4 C4, it is F3 C3. Lot of this coherence analysis were done. We created this type of analysis. Then even if you see F7 T3, F8 T4. So the coherence analysis gave us a clear message that whether there is a one-to-one link between the ECG and EEG signal or not. The idea of this coherence study was to see that whether there is a appreciable delta changes which is taking place or not in alpha, delta, beta, gamma, all these waves which you are considering, where it is actually really going in a measurable way. Then we found that the delta and alpha signal, delta is for dreamless sleep. When you want to a deep sleep, the delta wave is preferred. Alpha wave is preferred when you are going for this relaxation. Beta wave is for concentration. So therefore, alpha wave, this Anulam Vilam, the respiration approach which you do for relaxation, this is the alpha wave only. Then we found that without much difficulty, we found that there is a visible variation in alpha and delta wave due to the HRV changes. As you change your heart rate, as you go on giving exposure to the people with different mobile handset, then their HRV is going to change, that heart rate is going to change, and once the heart rate is getting changed, it is definitely has an effect on the EEG waves. And in EEG wave, the effect is without much amplification, without doing further processing, we could see that it is delta and alpha wave are easily readable. For beta and gamma, you need some more processing. So once we got two waves very clearly, we started working on that, and we wanted to see what is the one-to-one mapping. How really P is affecting, how the QRS is affecting, how the T wave is affecting. So it is like segmenting all ECG wave and also segmenting our EEG wave and bringing that correlations between them, that how they are linked to each other. So therefore, a lot of these coherence studies were done, and a lot of analysis were done. And the coherence study gave us the idea that, yes, this study gave us the idea that there is a visible change when there is a change of heart rate. And it was, means the study was not giving a very uniform type of things. You cannot really tell that if I give one unit enhancement, there will be 2 unit enhancement in EEG alpha wave. It is not like that. It was going through a random, and it was changing from person to person. Then we did some homework. We went through certain mathematical analysis, came out with a averaging formulas, and based on these formulas, we could see that this coherence and between the ECG, EEG, it is having a coherence coefficient which is giving us answer that yes, if you go on changing the heart rate, there is a possibility of changing the EEG or so-called the neurons effect. But that neurons approach was more towards biological, so it avoided that. We just played with this signal first, and these are the conclusions when we are we analyze the coherence. Then the idea was that we started going for the different type of linear, nonlinear parameter for HRV analysis. And in linear parameters, as you know, the mean study of HR, then standard deviation, then root mean square study, then the NN, the RR triangular index. If you see a lot of exercise we have done, these are all linear parameter study, the power in VLF band, the power in LF band, the power in HF band, the power in VHF band, then the low frequency to high frequency ratio, then the vagal. So these linear parameters, some are in time domain, some are in frequency domain. We started that sympathetic, non-sympathetic, this type of thing. Then in nonlinear parameter, we went for the determinism. Then you have lot of this type of probability parameters are also considered, and nonlinear parameter also correlation dimension, max line length, mean line length, recurrence rate. So a lot of these nonlinear parameters are also considered, because even the entropy analysis we didn't really take a chance. We wanted to go to the doctors that, look, we have, as engineer, whatever is possible in terms of signal parameters, we have brought the data in front of you, tell us whether there is a possibility or not. So that was initially very challenging, but ultimately all these linear, nonlinear parameter, when we were studying, and it came to our mind, let's have a t-test, because we must also get through a statistical results that what we are trying to get, what we are trying to analyze has certain statistical results in front of us, and it is giving us an answer that yes, what you people are doing is correct, and it has that objective can be achieved, that by changing the heart rate you can change the mind of the people. So that particular aspect, when we have started analyzing this, then we could realize our results are, even though it is drastically not giving you a visible answer in all the waves, but for alpha and delta wave it was giving a visible answer. And as engineer, we are not we are seeing the variation in the signal, but we are not we are not in a position to analyze that in terms of the medical aspect. So when the doctor came into picture and he started analyzing this, he told, this is a marvelous study which you have done, and it is definitely has an answer that changing your heart rate, you are in a position to control the different waves of the brain. Especially I am in a position to see the variation in the alpha and delta wave. Also, in the nonlinear analysis, if you see the distribution, these are all node points where the sensors were put, and in these node points, if you see how the high low value got changed when it gets exposed to the different type of signals, and this type of variations at different locations, we started collecting this database, and we also presented in front of the doctor to see how the delta power is changing, how the theta power is changing, what is the alpha power change. If you see here, it is very clearly visible. If you see here, in terms of the entropy study, in terms of the Hurst exponent study, then when we analyze that in terms of delta power and in terms of the alpha power, it is clearly visible, if you see. So it is in case of gamma, it is very less changes. It was difficult, but in delta also it was visible. We could see a lot of variations in that. So that is the way we see that it is giving us the answers which we are looking forward to. And finally, it has given us a strength. At the same time, when these two people, they got their degree, we could conclude that the thought process which was in our mind when we started way back in 2013-14, we are completely blind how to go about it. But as the time passes and these two people, they got their degrees, we could generate a lot of database, and that these are not the database which were downloaded from somewhere. It was all this experimental database which we created in our own lab in the presence of doctor, vetted by doctor. Now publications have been done out of this database, so it has been further vetted by the respective people. So now it gives an idea that Yes, as we look forward to a solution to the brain, there is a possibility that through heart, certain controlling activities of the brain can be done, and to the heart, the variation can be brought in through radiations, and this radiation can be external or through a skin interface where you can go for a radiation creating the perturbation or disturbance in the skin, and that skin disturbance can carry to the brain through your heart, and that is the way you are in a position to see that how the heart and brains are having a link, and how you can really control the brain of the any individuals by bringing certain heart rate changes in the individual person. So this is definitely is a preliminary study, may not be ready for immediate application to the medical science, but the medical science people are convinced that yes, there is a lot of positivity in this particular study, which has given us a path. It's aggressive or more detail, more inside or deeper study can be taken up in this type of area, then we can have a certain answer towards the brain-to-brain communications or heart-to-brain communication in a better way. So basically, we may not have a direct solution for a brain dead people at this stage or the people who are in the coma, but if we continue this study with some dedicated researchers who are having a fascination, a completely dedication for research, so they definitely can bring out some solution to this type of challenging areas. These challenging areas is like you have to deal with a lot of uncertainties. The uncertainties cannot be answered through a fixed boundary value problems. So as an antenna engineer, we look forward to a better boundary value solutions. This may not be the answer here. You may have to depend on more towards statistical study, and certain statistical studies are to be cross-checked by some other methods. So like that, you will have a mixed type of experience here, challenging experience. But if something coming out of this will be a lifetime satisfaction for you, that you could really deliver something to the society in terms of medical science. Without reading medicines, being an engineer, you are in a position to give a lot of contribution to the areas. So with this word, actually, I would like to stop here. I know that I was running fast. I didn't explain certain things well. This is under my compulsion. I'm sorry for that. Actually, in my mind, I heard that you have the program in November, but yesterday only Professor Raghavan, when he called, then today I had a overlap with another Untitled program, so I had to cancel that. I wanted to honor your the esteemed learners here, and especially I cannot say to a very respected person like Professor Raghavan, because he's one of the most esteemed professor in front of me. So that is the way I'm here. So I'm sorry, participants, if you have some questions, please raise this question in my email ID. I'll get back to you. It is I am a person, I don't really don't answer to email. It is not like my nature. Definitely, even if it is late, I'll definitely answer your queries. But I look forward to a situation where my experience, almost all 30 years in these areas, says me that in silo you cannot really deliver. So if you are pursuing your research as a silo researcher, please keep out of that, come out of this cell and create your team. Unless you create your team, you create your network, you cannot attack system level problems, and system level problems requires multi-dimensional, multi-degree, multi-variables solutions which you cannot really find out. Therefore, you must create a team. And definitely the RF requirements in the biomedical areas, the RF requirement in medical science, day by day, things are really moving fast. And if you can utilize your computational power, your thinking process, your antenna experience, link into a slightly offset type of field like the biomedical, it will be very interesting area to explore. But it is definitely at this stage is a challenging area, because the doctors, they don't understand your language. Because when we published our the first biological driven optimization technique algorithms, this IMBO, you might have seen that swine influenza model based optimization technique. We have given an original algorithm to the optimization or subcomputing world. That time in 2008, I used the swine flu, see how the swine flu process can be stopped and how the global pandemic can be stopped. So we just saw their virology paper and we went through this virology paper. Then we studied that. Then we created equations, mathematical equations, and a lot of these equations are used. And ultimately, one optimization algorithm was developed, Simbo. That time, my interaction with the doctor was very vigorous, and I could read that they will not understand engineering language, and you have to find a way out that their medical language you have to convert yourself, you translate yourself to your engineering language. And luckily my counterpart doctor also did that way. Our engineering language he started translating to his medical language, started understanding it. Finally, after 4-5 months of differences, we decided, yes, we have a common interest, let's go for it, and we could achieve that. But here in this study, I didn't face that much of problem because luckily I got a senior cardiologist as my doctor here. So he helped me, and with his support, we got a neurologist from PGI Chandigarh who also appreciated our work and participated in our work. So we created a team. So these results which I am showing you, it is a vetted result of vetted by doctors. So more or less it has been accepted by the doctors community. So maybe you can think if you have a family person who is a doctor, then it will help you further. So I look forward to you people to take up similar type of works in your organizations, and it has a lot of field. Thank you so much.
Thank you very much, Shamsundar sir. Dr. Raghavan sir, you are the right person to say a few words about this session, sir.
Sir, I just want to tell two things before Dr. Patnaik goes to ministry. One should not throw ethics, whatever may be the testing period comes. Here is a person in the world, I am telling in the world because I know everyone, who has thrown the vice chancellor post for the cause of ethics. He is none other than Dr. S.S. Patnaik. The second thing I want to tell, immediately after his education, he has gone to America to work with O.P. Gandhi and also against Nokia and tell what are the cell phone effect, biological effect. So he was one side, all cell phone manufacturer, the other side, he has very boldly, like today, he has come out what are the biological effect of microwaves. He did a PDF and he's almost like academic brother of Dr. R.K. Mishra. That is the first thing. Second thing, I can very authentically say his group was the first group, as he told, it is Joshi's antenna. That was the first group who did textile antenna in our country. Then only the so-called Anna University group came. So that is the second thing. Many more things. And he is able to do this much work in biological effect because his campus is very near to PGI Chandigarh. So that way, it is not simply for journal counting. He has really gone into this. Before I am handing over to this team, Dr. Mahadevan has told, I would like him to tell also, and also some students have told, is it a dream or reality? Likewise, Mahadevan's one sentence will come before the organizers, their usual wonderful comment on this speaker. 1 minute to Professor Mahadevan.
So thank you for the opportunity. It's such a great lecture. And mainly, I find that the amount of data which you need to collect with various conditions is so difficult. And you are done, and with such great database, now it is for them to really interpret, and then finally we should give a signal to the general public. So that is what is the final thing which we are now really looking for. So I think your students who have done extensive work on this should be able to do that and then give the information and to both the medical field as well as for the general public. So it's a great lecture to have attended.
Sir,
thank you so much.
Great to hear your voice after so many years. Actually, I remember this Haridwar period. After that, this is great to hear your voice, sir. And Professor R.K. Mishra is there, sir. He is not my academic brother. He is my physical brother also. Like we have different parents, no doubt, but he is my elder brother. I would like to see him actually.
We called him at the beginning. I think now he will join. Dr. R.K. Mishra, sir.
Hello, am I audible now?
Yes, sir. Yes, sir. Audible,
Yes, sir.
sir.
Yes, sir. You are.
Thank you, thank you. From yesterday, I am getting problem in my audio. I could not join in the beginning. We go a long time back, starting from our days at REC Raulkela, where we are student. I was just 1 year senior to him in the batch, in terms of batch. That's why he calls me Kishore Bhai. Kishore is my pet name. And we shared the same room during our research period. Then till today, we have stayed like a close-knit family. We know each other, not only each other, we know the families. Our families are also well linked. So that is one of the major things between us, two people from two different places. Although we don't have the same parent, but his parents considered me like a son, and my parents also considered him like a son. Unfortunately, both parents have deceased by this time. We are alone now. Now let me come back to the effort he puts in. He will, for the young researchers, I'll tell you how we did our doctoral work. When we started, there was one PC, no DOS, a CPM system was there. There was one PC in the electrical engineering department. We were in the electronics department. So during daytime, we had no access to that. What we used to do is early morning, we will go there and get the key from the teacher who was in charge of the lab and go there, work till 8 o'clock. So from early morning to 8 o'clock was computation. This was in the beginning. Then we thought that this is not sufficient. So then we started staying in the night, whole night. There are many nights we have spent in the lab in the competition and performing experiments. You will remember many days we have spent in the lab instead of coming back to hostel and staying there. So mostly we do that. Sometimes we take some tiffin instead of lunch or dinner. But just taking tiffin, we used to stay in the labs. So that was the grinding. Both of us, we enjoyed that, but we sweat also. Nowadays it is much more easier for the students. The other problem was our supervisor was very strict, and we have to get courage to meet him and discuss our problems. He said that don't come to me with problems, come to me with solutions. This is the problem that I am giving to you. You come to me with solutions. So that was a very difficult time, tough time. Nowadays, it is just opposite. The students say their guides that, sir, I have given you the problem. Now you solve it. And after 6 months, they work with you for 6 months. Then say, sir, where is my paper? Why paper is not published? This is happening with many people. Today morning session, Dr. Rao gave a very good account of how to publish. So, you know now the situation. If you know the situation, then going through that process is very difficult for the students, for the mindset they have. Of course, I am not saying that everybody has that, but many people, many students nowadays, they are not serious about the study. What they do is what we didn't do, and what they do is two different things. We never followed a paper and repeated it. We took a problem, tried to solve the problem. When we got into problem, we go went back to books and reference papers to see what can be the solution. So that was the profoundness involved in the work. Nowadays it is just opposite. Students take a paper, good paper, then they will change the data. Suppose there is a microstrip antenna, length is 4 centimeter, width is about 4.5 centimeter. Then student will take another microstrip antenna, length is 8 centimeter, width is about 9 centimeter, and they will try to publish the paper. Just make some documentary changes or ornamental changes in the language, and they will send it to another journal. So that is not advisable. That is very bad actually. That reflects bad on the country. We were in those days, we were the leaders. India was the leader in electromagnetic field. Antennas or microwave, with people like Professor Viendas, Professor Bharati Bhatt, Professor Saraf. So those people were around in the academics. We looked into them. We got their advice when we required, and we gradually we came to the stage where we are now. That is not happening now. Nowadays, students feel they know everything. Either they know everything because they have these software packages, and they put pressure on the guides, supervisors, if the supervisor is new.
Kesar bhai, actually it is great to hear you after so many months. I hope you have started recovering well. I'll give you a call. Actually, I have to take a leave now. 11:30 I have to join another meeting.
Give me your phone number. तो phone number काम करनी. मो पाके जो टाची काम करनी. मो phone number change है नहीं तो वाटे SMS करते.
Yes, I'll do that. I'll do today. Okay. Today, after this meeting, I'll do it. 3 o'clock, I'll be free. After that, I'll do it.
Okay.
So, Raghavan sir, namaskar, Madhavan sir, namaskar, and it is really wonderful. I'm really sorry that I have to now exit because the other meeting is...
sir.
Sir, one minute, sir. This they will complete their formality.
Oh, okay.
Okay. Yes. Thank you very much, Raghavan sir, Mahadevan sir, and Rabindra Mishra sir for your kind words and wholehearted support. And thank you very much for your valuable knowledge with us and for sharing your valuable knowledge with us and for being with us today. Thank you, sir. Shamsundar sir, Patnaik, very much. Thank you.
Thank you, sir. And Perumal Shankar, thank you, sir.
Thank you, Professor. Thank you, Professor.
Thank you so much, sir. Thank you.
It is wonderful. I'll be in touch with you people. Thank you so much.
Thank you, sir. Thank you.
Dear participants, you can send questions to sir's email ID. Sir will get back to you.
Actually, madam.
Sir Raghavan sir, Diba Miss has left the meeting. She is having thanks, ma'am. Yeah.
Sir.
Hello.
Hello, sir. Hello. Mahadevan, sir?
Yes. Yes.
Hello.
Please. Hello.
Yes, sir, I can hear you, sir.
Yes.
I think we can have the technical festival like yesterday. Dr. Sudhakar Rao has come. Around some 20 questions are there. Participants will be very happy. I apologize to Dr. Sudhakar Rao for this small break.
Okay,
No problem. I enjoyed that.
HOD is coming now.
Yes, welcome back. Thank you, sir, for the wonderful session we had today morning. And due to our strict time schedule, we were not able to discuss the questions that had come up in the chat box. So we'll put forward those questions to you, and you can discuss. All the participants are eagerly waiting to hear from you.
Sure.
Okay, sir.
Dr. Rao.
Yeah, welcome.
Dr. Rao, can I put 2 words to 2 sentences?
No, sure. Go ahead.
Okay. Please advise them to go through the editorial article of T.S. Bard, Trevor Bard, when he was the editor. He had written one article on how to prepare a publication paper and how to go for publication. I think towards the end of his tenure.
Right.
So that will be a great reference, handy reference to the people, those who want to go through that. After this, if they forget anything that you have told, they will find it in that article. So that is one point that I wanted to tell you. And the second is, I will be a bit selfish if I say this. Randy publishes a column on ethically speaking in the AP magazine. I had one article in that sometimes back in 2003. 2003, there is one article which talks about plagiarism and how people are choosing predatory journals, how to avoid that. So maybe people can refer that if they want to avoid plagiarism. So these are the two comments. Otherwise, I enjoyed your talk also.
Yeah.
So with that, I will rest.
Thank you, Professor Misha.
Sir, Dr. Sugdagar sir will share our window.
Okay.
Sir, is it visible for you?
Yeah.
The questions are visible.
Can you increase the font?
Yeah, I can increase.
Okay, I can see that. So first question is, how many publications per year is a good researcher expected to produce? I think there is no norm for it. I would say a good researcher, if he publishes one publication per year, I think it's great. But make that one publication be the quality publication, not. You might publish 3 papers, but if they're average type papers, I think it's you won't get recognition. So I think it's always not the quantity; it's always the quality. So I think one good I know a lot of people who got PhD with one publication itself. So those things are again, I think there's no norm for it. Typically, you need like 2 publications, I believe, minimum, and maybe a couple of them in conference papers and maybe other journals. So IEEE, you need maybe 1 or 2 publications to complete the research, but overall, I would say maybe 1 or 2 in IEEE and probably 2 or 3 in other publications, but just make sure that they're quality papers. Okay. The next one is simulated result enough for submission in journals? Depends on what you're simulating. If it is a new area, I think sometimes you cannot measure it, so simulations are good. It's always not you simulate, you measure, and that's not needed for publication. But if you have it, I think it's good because you're basically showing that your analysis and simulations match with experiments. So that gives a bit more credibility to the paper. But sometimes you cannot publish it. So if the area is relatively new and you have only simulation results, I think that's fine as well. Okay. Comparatively, Indian publications are lesser. China, South Korean publish more IEEE papers. Your expert comment, please. That is true because I think especially South Korea, I think they publish a lot of good papers because they have a large industrial base. So all the universities are affiliated with some industry, either Samsung or some big companies. So big companies also get their research through university, collaborative research. So I think they publish quality papers. China, I think they're again do a lot of quantity, but quality is dropping down now. So there's a lot of issues with people from China. Indian publications are less. Yeah, that's true. So I'm not sure why. I think before, when I was doing PhD, I think IIT Madras and IIT Kharagpur used to be on the top. Of course, Professor Narasimhan, probably the foremost antenna researchers in India. I think he single-handedly produced more than collectively what IIT Kharagpur has produced. So I think he has won 7 papers in IEEE publications on horn antennas, IEEE book, edited by A.W. Love. So based on his research at IIT Bombay. So that itself is a big honor for India. Nobody else have more than 2 or 3, I think, in that. So beyond us, I think I would say probably the second best I've seen in India. Both are my teachers and mentors. And people forget actually the Professor Saha. I think he did wonderful work. He published only 2 papers, that too in IEEE AP on corrugated horns. So those are fundamental theoretical papers, first time published in corrugated horns. So along with PJB claricords. So when I was doing postdoc in Norway, claricords came, and so then of course he offered me postdoc. I didn't take it, but I went to Canada. So that time he told me the brain behind this work is P.K. Saha. So he used to tell me the wonders he used to do, especially with the analysis part and the type of research. But he told me privately, but publicly he never gave credit to P.K. Saha, which I still didn't like that much. But I think I would say I will rate him as one of the top 3 researchers that India produced. He didn't have quantity, a lot of papers, but those 2 papers are worth more than maybe 30, 40 publications. So nowadays we are not seeing that. I think everybody is looking into only patch antennas or something like that. Before, I think we used to do reflector antennas, horn antennas, slotted arrays, a lot of things, but they're not doing that much. So I would sort of recommend academicians to look into the problems which industry needs. At the same time, industry also had to work with academic institutions. So collaborative research is important. Okay, the 4th one is publication versus patent. Which is better to consider? Always patent has more value because it takes more time. It's difficult to get a patent. Takes probably 4 years by the time you get a patent, once it's approved. But publication is, you don't need to wait that long, probably less than a year, sometimes even 6 months you can publish a paper. So I think patent has value because you have a commercial product coming out of the patent that has a lot of